Earth as we know it is a place that mothers all nature filled with sea and partially land. With that being said, pollutants are at large creating a major issue in today's society. Furthermore, industrial water is one of the major contributions to environmental contamination. This is because a high chemical oxygen demand level, or COD for short, is more than 1000 mg per liter will cause the release of noxious gas, resulting to a polluted environment. Consequently, the Malaysian government released a law stating that the range of COD has to be within 120 to 200 mg per liter before being discharged into the environment as a method of overcoming the issue of pollution. With consideration of the new challenges the world has for us with regards to the current affair, it is obvious of the importance a control system holds in an industrial plant, as it is able to achieve an effective removal rate and also with minimal cost investment. Hence, the objective of this presentation is to review on the control system in the water treatment process of Company S.
Normally, the wastewater treatment involves three stages: primary, secondary, and tertiary stage. Primary stage involves physical and chemical treatment to remove floating and settable materials such as suspended solid and organic matter. Equalization tank usually is the first stage where the impact of toxic compound in the wastewater is being diluted, and the pH is neutralized in this stage to minimize the downstream chemical usage. Primary stage also involves chemical coagulations to neutralize the charge of the particle so that the particle can stick together and form larger particles which are more easily removed. Secondary stage is where all the biological treatments such as activated sludge process or anaerobic digestion happen to remove all the biodegradable organic matter and suspended solids. The last stage of the wastewater treatment is usually called tertiary treatment, like membrane technologies such as microfiltration or ultrafiltration is applied in this stage before the wastewater is being discharged into the public sewerage. Every company will have their own wastewater treatment, and this is piping and instrumentation diagram of wastewater treatment obtained from Company S. The piping and instrumentation represent all the major equipment like EQ tank, coagulation tank, valve, pump, process parameters, and control system. The control system in this PMID diagram consists of transmitters such as flow meter, flow transmitter, pH transmitter, level transmitter, and also the local control panel and mixed signal controller, and the programmable logic controller, as well as the human machine interface panel.
To review on the control system, the section from the PNID provided by Company S that will be discussed is the coagulation and flocculation tank. This is a screenshot of a section from the PNID. Incorporating a coagulation and flocculation tank along with 4 dosing units, feed from EQ tank 1 flows into the co and floc tank. The pH transmitter that was lodged in the tank will operate as a sensor. When there's a fluctuation in pH value in the tank, the transmitter will dispatch electrical signals to the analyzer indicator in the MPC and LCP. The analyzed electrical signals will then be generated and transmitted to the PLC, converting these electrical signals to digital signals and determine the deviation of pH value in the tank from the set value. Subsequently, electrical signals containing data on appropriate acid or alkali dosage will be sent to the motor controller panel, MCC. MCC comprises auto provision that derives the mechanical action of the motor to alter the amount of acid or alkali towards the injection point. To further enforce the control system in the process, HMI touchscreens panels are connected to the PLC system to allow human operators to monitor the processes from different places. This HMI panel is able to show all statistical data obtained from the system in a trending graph to allow the operator to analyze the change in the tank easily. As this control system involves both HMI and PLC, It is said to be a SCADA system, also known as a supervisory control and data acquisition.
A SCADA system is widely used in industry. It also gives massive advantages on the controlling the process parameters of wastewater treatment. It is capable to detect an issue using diagnostic display while enabling quick intervention and fast resolution. Other than that, SCADA system benefit both data management and process operation optimization. It can also support the maintenance work and ensure optimum operating mode in the event of damage. To support the claim, the efficiency of the coagulation tank is scrutinized by evaluating the pH profile generated in the coagulation and flocculation tank in the system. With MMPC embedded in the PLC system, the fluctuation of pH in the coagulation and flocculation tank will be resolved as the PLC is able to track the reactiveness of the MMPC prior to the change of the set point in the tank and show a good performance to give a very fast response to the change in order to achieve an effective dosage control in wastewater treatment process. The MMPC is able to reject the disturbance that were introduced into a tank and able to maintain the pH level at the set value in a very short time, approximately within 1 hour. From the data obtained, the MMPC detects a sudden drop of pH when the disturbance is first introduced into the tank. However, the correction is done by altering the dosage of the chemical from the dosing tank within a short period of time to make the pH value of the tank back to the original set value. Therefore, the system is satisfactory in coagulation control in wastewater treatment plant.
In conclusion, the only manner in which an improvement could be done on the system is by making PLC wireless. This means that it connects wireless LAN with Ethernet ports. By doing so, money usage on wiring costs will be cut down, as well as the time that would be required to connect and commission the control panel will be eradicated. Thus, this system can be further improved by making this control system a wireless system. How so, you may ask? Well, the cost also would be minimized this way, where the installation and maintenance costs from the existing control system can be neglected. And since it is easier to install a wireless LAN than the wiring in the existing system, time consumption of the installation of this new improvement would be much lesser. Sadly, this was the only manner in which an improvement could be done, since SCADA is the most advanced control system out there today, with little to none room for improvement left. Trust us when we say that we spent a handful of man hours of research.